Okay, you'll have to pardon the low-tech slides. I'm not very good at this stuff, and if I stumble, I'm also not very good at doing remote speaking. So the title of the talk, as you can see, is Using and Not Using the Open Science Grid. We thought that it might be useful to get a perspective both on things that were appropriate for it and also perhaps on some things that we deemed that were not necessarily so appropriate. Where did I come from? So you can assess my credibility ahead of time. I have an undergraduate degree in medieval history. I went to graduate school after a couple of years trying to find a job in statistics. That helped me find a job, and I worked in statistical consulting and statistical software support for close to a decade, at which point I switched over to more straight ahead system administration. I worked on several large-scale distributed Unix environments. At one point, we had hundreds of servers, 30,000 users, and approximately 3.5 million unique logins every month. Most of the areas that I've worked in are social science and mathematics, but I do have some experience with psychology and a little bit with some biology. I was a system administrator officially for the math department, but we shared a building with the psychology department. And when they found out I could do Linux, they came by and said, hey, could you help us? We do magnetic resonance imaging. So quite by accident, I became a co-founder of something called the Neuro Imaging Initiative here at the University of Michigan. It's a consortium of departments across campus that have mostly MRI, but a little bit of EEG and occasional MEG on human subjects. I found out about the Open Science Grid primarily because somebody said that they were offering FreeSurfer, which is a software package that does structural brain image analysis. We had originally thought to move a lot of our image preprocessing for the human MRI to Open Science Grid. We thought OSG would be appropriate because we have many subjects, each of which has many steps. Everything is very production line. And then there's a package called Neuro that will allow you to set up a Debian machine with a bunch of these MRI processing software packages already involved. As a consequence, then I applied to the summer school, primarily to support the human subject neuroimaging. I'll let you read this. I have nothing but great things to say about the summer school. It was wonderful. It was a lot of fun. I think the folks at OSG rock, so I'm biased. And I think it is excellent preparation for people who are going to go learn about HD Condor and Open Science Grid in preparation for training others to do the same thing. Here at Michigan, we have had a few more subjects in this, but these are the primary ones. As I said, have been saying all along, human subject neuroimaging. People came to us to see about OSG. We've had some people from engineering simulations talk to us. And then we've had two projects from the School of the Environment, one which is doing tree cover mapping and one which is doing a fish migration project. The human subject neuroimaging turned out badly for them and for me and for us. There was some software that was not provided on OSG that was needed, but there was some that was. We did not have HIPAA data, so we didn't have to worry about that. The University of Michigan Institutional Review Board approved all of the data for limited distribution for research. We had a lot of data to transfer, and that was an issue, but the real kicker was that the data was not deemed by our compliance office to be open enough to use on Open Science Grid. So that kind of put a stop on that project. So the next project that we looked at was somebody contacted us about an engineering simulation. The software was compilable. It was unrestricted code. It's essentially simulations with small inputs. There were thousands of replications that were wanted. Again, the input data was proprietary, and so the data turned out to be the stopping factor between us and being able to use OSG for an otherwise totally appropriate project. So this brings us then to the two other projects, the trees and the fish. These were run out of the School of the Environment and Sustainability. These are master's degree projects. So this is an attempt by the school to get the students to do semi-independent research, write up their results as if they were working for a consulting firm. The projects are unfunded. They're group projects involving multiple students, and the actual scientific topics come from a variety of sources, most of them from nonprofits and from local, typically municipal, either city or county agencies. The students have a research question and program, and they have to start and finish within one semester. So they have to get everything set up, written up, analyzed, and graded in order to complete their degree. So some of the challenges that we faced with this layout of people and projects is that graduate students in the environment are typically unsophisticated users, which I suppose all of us were at one point. So there was a fair amount of training that was required for basic Linux commands. Nobody knew how to use any text editor that didn't run on a Mac or a Windows machine. Virtually none of them had any shell scripting experience. They were very unfamiliar with data transfer programs that weren't things like Google Drive or Dropbox. Training was obviously required for HT Condor. And one of our biggest challenges, of course, is the short timeline, because there's an awful lot you have to learn in order to become productive at something you don't know anything about. One of the other challenges is the software. The students were using, one project used R, the other used Python. Both of them had many tens of libraries that needed to be installed. That's not a good scenario for Open Science Grid, where the software typically needs to be copied to the node that's going to run the code. So the solution to this was to use Singularity. One of the challenges with Singularity is that the students are typically unable to create the containers independently. So the support staff, which would be myself and my colleagues, pretty much had to do the software installation and configuration for them. That could be a barrier for people who are working at places where the support staff is not quite as filled up as we are. So the data restrictions, we did have very light restrictions on these data. In both cases, the data are fully intended for publication and open public access by the government, but they were in a pre-release state, so the full quality analysis hadn't been done. And I think that as home campuses seem to be restricting access to data and machinery that holds data, the choices that are available for automated data transfer are becoming more difficult. One of the earlier talks dealt with a system that could very well address that, and that would be really cool. But we used the OSIRIS project. Unfortunately, it's currently unfunded and is on a best effort maintenance basis. So these capstone projects, the first one was an R analysis of some LiDAR images. These are essentially light reflectance taken by an airplane that's flying over. The job takes the raw LiDAR images, converts it into an image, tries to figure out where the trees are, isolates the trees, and that then is taken back to the people to see how well the expansion of green spaces is proceeding. We used S3CMD. There's an S3 interface to the OSIRIS system, which is natively Ceph based. Every job did its own S3CMD to transfer data from OSIRIS, process the data, and then did another S3CMD to put the data back onto OSIRIS, where the students were able to get to it. There were several thousand files. Processing time for each was somewhere between 2 and 4 hours. We had 4 students in the project. All of them were able to use OSG. Each of them processed approximately a quarter of the data. So we thought we did a pretty decent job with our educational mission there. The next project is this fish migration. This is Python. We have some remote sensing equipment that's set out in a newly opened connector between a restored wetland and a riverine tributary. The sonar data is measuring fish that are swimming by. The sonar data gets converted into MP4. The MP4 data, basically that's what we're using the OSG for. There are about 50 or so images per hour, and we would typically we broke that up. So there ended up being tens of thousands of files that needed to be converted. Again, the data transfer was the same per job, down with S3 and then back with S3. Unfortunately, only one student was doing the work, though that's less of a reflection on Open Science Grid and more of a reflection on the student in the project. That also worked out quite well. So far, as you may be able to gather here, the biggest barrier to our using Open Science Grid so far has been data restrictions and the data access policies and data transfer. And as a summary, I would simply say that anybody who's looking at human subject data, you want to make sure that you're aware of any restrictions that may be placed on you administratively by your institution. We were very fortunate that Osiris provided a common file system that did not require a VPN clients or any special certificates or anything like that. And I would like to say that training users to use OSG is certainly no harder than training somebody to use a local HPC cluster. In some ways, the students that I was working with, I thought it was a good deal easier. So I don't think that that's a particular barrier for people who are new to either high throughput or high performance computing. We think that Open Science Grid succeeded extremely well for the projects in which we used it. Again, we were using OSG Connect, so there was no cost to the students, and that was the key feature that made it practicable for us to have the students do it. And then once again, I would reiterate that the summer school was extremely good preparation. I came back and felt like I had a good enough handle on things that I could help others do this. So suggestions for the future, clearly, I'm not the only one who's thinking this because there's already been one talk trying to solve the data distribution problem. A lot of the sources of this come from our own institutions and they have nothing to do with Open Science Grid. But if people find solutions to them, it would be great to publicize them and make a catalog of how I got this data to work with Open Science Grid. I know I would certainly find that useful. If there are campuses that have their own local resources that are part of the Open Science Grid pools, you may be able to use your local resources that have direct access to data for those projects, hopefully few or not, so that the resources are on your campus and have direct access to that data. And I personally think it would be a really wonderful idea if there was some way that Open Science Grid or the community could create a kind of an open science boot camp for HD Condor people who are thinking about installing machines and making them available to Open Science Grid. That would allow someone at an institution that doesn't already have this to do a proof of concept, which might help for local adoption and participation in the Open Science Grid. I attended a similar workshop that was offered by TAC, the Texas Advanced Computing Center, for their Open HPC system. And I thought that was really wonderful. And I learned a lot of things that were directly applicable to the cluster that I have here at home. So that's pretty much everything that I have. I will stop sharing and allow people to ask any questions that they might have.
Thank you, Bennett. We do have several minutes for questions. And again, you are welcome to raise your hand or throw a question in the chat so we can make sure to get to it.
Let's see here. There was some stuff in chat. This looks like it's all on open on demand.
Yeah, I think
sorry, Tim. I didn't mean to call you by the wrong name. I hope you'll forgive me.
OSG User School, we forgive you.
No worries, Bennett.
I hope I didn't call it anything that was insulting.
No. It does happen in the summer, so.
Right. The public, we did look at public, and unfortunately that does make it available via essentially an open public web server. And that was what caused the local people to say, we're going to do that. We're going to do that, but we're not quite ready yet. So please don't put it someplace where people can go and get it and then say we got them the wrong data later.
Yeah, I was just to
Christine
clarify
has her hand up.
yeah, sorry, before I jump to Christina, I'm gonna just clarify too, the /public location, as I mentioned in the chat, is the mount of OSG Connect's data origin. So that is where users on OSG Connect access points can place data to be integrated with the Open Science Data Federation through the caching mechanisms that Frank and I described just before. So that's what Bennett is referring to there. And regardless, I know there are sort of different levels of protection of data, but even as we pursue more private options or sort of like per user permissions options for making data accessible to jobs that run across, say, the Open Science Pool, it is still the case that data exists, at least temporarily, on somebody else's servers where who knows who has administrative access. And so those are sort of in the gray areas of when you can and cannot use certain types of data based upon whatever restrictions your campus has or are relevant to that particular data.
Right.
I'll call
it's a
it
minefield.
Yes, it can be. And we always have to caution researchers to double check with their IRB and make sure that the way that they're using our systems is acceptable. And we can also help to provide descriptions for exactly what that means.
Right. And there may be a compliance office that's entirely separate from the institutional review board that you have to go through also. So Christina has been patiently waiting.
Yes.
Nodding.
Yeah, that's okay. Yeah, Bennett, I was just going to ask how these different research projects found you on your campus. Is this just part of your role? You're affiliated with these different departments and groups. And so people are like, oh, Bennett, the computing guy, we're going to talk to him. And then when you see a good problem that might work for the OSG, you direct them there, or yeah, how does that process work?
How does that process work? So it works all of those ways. I've been at the University of Michigan for a very long time. I don't have the green verdigris that some of the statues have, but it's close. The people from the School of the Environment found us because they were submitting tickets to the high performance computing help desk, which is where my day job is, I guess you would say. And so we were looking at their project, and of course, as soon as money comes up, they said, "Oh, we're going to have to go somewhere else." And so that was when I said, "Oh, wait, don't go. We have this other thing that might work really well for you guys." Once the first project actually got off the ground, then the people at the School of the Environment said, "Hey, if anything comes up, there are these really helpful people over at the HPC who will put you somewhere that doesn't cost money." So it's a lot of this is the free stuff. As I said at the beginning of the talk, the psychology people, I mean, I got into that by accident because I happened to be the only Linux guy in the building. And somebody came and brought me flowers and chocolate and said, "Please, will you fix my computer?" And the next thing I knew, I had an entire floor of groupies. And I had root on, more machines than I'd had since I had run the campus infrastructure. And then others, it's word of mouth. I got one person made inquiries, the engineering simulation, knows somebody who's in my running group. So connections are serendipitous.
Yeah. Okay. Thank you very much.
Yeah.
Yeah. And
And Anirban?
we've got one more. Yes. Anirban, and then we'll move on.
I had a question for you, Bennett. Since you've been working with students on HPC, I was just curious, do you think it's a better idea to just get more involved with HPC in just the undergraduate curriculum, or should we be looking at high schools? Because high schools typically we stick to like STEM, and that's been the current thing. Do you think there's any room for HPC in high school, and how would that look like?
So high school has changed a lot since I went to it. If you haven't been able to gather, I finished high school in the 70s, and computers in high schools was not a thing. So these days, the number of people who are taking AP would probably be able to find things that they could do with HPC, but I honestly don't see many high school curricula naturally finding a use for HPC. It would be an artificial use. I think that if you were going to teach people something in the high school curriculum, you would be better off teaching them about things like multi-threading, which can be done on a single computer, including a Raspberry Pi. There are configurations out there that will let you set up a little computing cluster. You could do an Open Science Grid HT Condor on it just as well as you could do an MPI configuration. I know I bought a stack of 4 Raspberry Pis plus a little login node, set up an HPC, and was running MPI run with a host file. I've got a friend from the mathematics department whose kid was into this stuff. He's 11 and he's doing HPC on this stack of Raspberry Pis now. I also think he's an extreme outlier. He's a nice kid, but he's an outlier. So if you had a program where high school students were coming maybe between their junior and senior year, or in their summer after their senior year before they go off to college, and there was some kind of program that was trying to get them a leg up on what college level research, scientific research was, and it was natural for that scientific domain to be using HPC, that would be the place that you would probably want to catch them. I think there are many other things that would be far more important for them to learn while they're actually still in high school and part of the high school curriculum. Sorry if I went on at length about that.
Thank you, Bennett. It looks like there also maybe is a comment in the chat too, but we'll move now to our last speaker just so that we're keeping time.